Unsaturated vapor and dry air contains in a constant volume metal vessel. The system is maintained at a temperature of 27 degrees Celsius. The pressure inside is 120 mercury centimeters. When the temperature of the system is increased up to 47 degrees Celsius, find the new pressure of the system. Saturated vapor pressure of water at 47 degrees Celsius is 18 mercury centimeters. Moving into the second part of the questions, when the temperature of the system is decreased up to 7 degrees Celsius, small layer of water is visible at the bottom of the vessel. Find dry air pressure at 7 degrees Celsius and find the total pressure of the system. Right. So when we are doing this question, we need couple of equations. So let's get into the equations first. So we need gas laws equations here. We have Boyle's laws, P1 V1 equals P2 V2, and again the base equation is this PV equals nRT for ideal gas. That means here we have to, all these equations we consider that the total number of molecules or the total number of moles are same, that won't change. So Charles law V1 over T1 equals V2 over T2, and pressure law P1 over T1 equals P2 over T2, and combined gas law P1 V1 over T1 equals P2 V2 over T2. So all the temperatures must be included from Kelvin, right? So let's get into our question first. So here they are telling at 27 degrees Celsius we have unsaturated vapor, right? So that means from we can apply gas laws. So in unsaturated vapor, when it is increased, when the temperature is increased, new molecules will not come into the vessel. So that means we can apply gas laws, ideal gas laws, we can apply it here. So they are asking us to find a new pressure at 47 degrees Celsius. So we can easily apply gas law P1 over T1 equals P2 over T2 because the volume is constant here, right? So initial pressure they have given as 120. So let's consider mercury centimeters. Then temperature, yes, we have to apply it from Kelvin. So you know how to convert Celsius into Kelvin. So then it's 300 initially. Then new pressure, let's say P2, and the new temperature 47 degrees Celsius, right? So then 320. So here we are getting P2 equals 120 divided by 300 into 320, that's P2. So let's simplify it furthermore, right? And 20 from 0 0 4 10, so 128 Hg cm. That's our answer here, right? In the second part they are telling they are decreasing the temperature now of the system, right? So now the temperature is at 7 degrees Celsius, and most important thing they are telling a small layer of water is visible. That means the system is saturated, right, with water, right? So at 7 degrees Celsius we have saturated vapor pressure plus dry air pressure. So in the first question they are asking us to find the dry air pressure, so that we can apply gas laws in this way. P1 over T1 equals P2 over T2. In the first scenario, yes, at 27 degrees Celsius, yes, we can apply gas laws. But moving into the second scenario, at 7 degrees Celsius, now we know the system is saturated. So when the system is saturated, actually we cannot apply gas laws. So what here we have to do is we have to separate the dry air and the vapor. You have to get them separated, right? So now at 20 degrees Celsius we have 120 Hg/cm. So it combines with dry air plus vapor, right? So that means they have given us at 27 degrees Celsius Hg/cm 8, that is vapor pressure. So we can remove it. So 120 minus 8, that's dry air pressure. So 112 Hg/cm we have dry air pressure. So we can apply gas laws to this dry air pressure now, right? So P1 over T1 equals P2 over T2. So here pressure, initial pressure 112 divided by 300, and P2 divided by temperature 7 degrees Celsius. Now it's 280. So then from the simplification we can get P2 equals 104.5 Hg. In the last part of the question, now they are asking us to find the total pressure. Right now we know at 7 degrees Celsius we have dry air at 104.5 pressure. Right, they're asking us to find the total pressure. So at 7 degrees Celsius we have dry air plus saturated vapor. Right, so dry air pressure it's 104.5 mercury centimeters, and saturated vapor pressure at 7 degrees Celsius it's 10 mercury centimeters, so 10 HgCl. So we get 114.5 mercury centimeters. That's the total pressure at 7 degrees Celsius. Alright students, now if you think this is valuable and helpful to you, share it with your friends, study together and win together.